Okay, let's start. But this problem, the mechanism shown consists of a crank OA of 0.2 meter, a connecting rod AB 0.8 meter long, and a piston at B. The piston movement is horizontally as shown, so we can see that the piston is moving right or left, right or left. The crank rotates at omega OA 15 radian per second clockwise. So the given here is the angular acceleration of, the angular velocity of the member OA, and it equals to 15 radian per second. So we'll start by the member OA. This member is moving, or its motion is as rotation about fixed axis. So the first thing we're gonna do, that we'll draw the member itself. This is the member OA, and the omega was giving omega OA. So now we can have the velocity A. Why the velocity A was in this direction? Because the velocity is gonna be perpendicular on the length OA. In which direction? In the same direction of the omega OA. So this is the VA, and it is perpendicular. So the VA equals to omega OA multiplying OA. Omega OA equals to 15 times OA, which is 0.2. Therefore the velocity of A, let's make it in another, VA equals to 3 meter per second. The remaining thing is the angle. This angle was 30 degree, so this angle will be 60. So we found the velocity of A. Let's take the next member, the member AB. The member AB is not rotating around the fixed axis, and definitely it's not translation. So the member AB is general motion. Member AB is general motion. But before going and start analyzing the member AB, we can see that the member AB is inclined with an angle phi. So we need first to get the phi. The phi is in the triangle OAB, and we know already the 0.8, the length of OA, and 0.2, the length of OA, and 0.8, the length of AB, and the angle OAB, which is 30. So now we can find using the sine rule. So we can do it like this, using the triangle OAB and using the sine rule. We can know that 0.2 over sine phi equals to 0.8 over sine 30. So we can find that phi equals to, let's make it in another color like red. Phi equals to 7.18. This is the phi. Great. So we're gonna draw the member EB. The member EB was as follows. Here it is. This is the A and this is the B. And the velocity of A was in this direction, and it was 3 meters per second. And the velocity of B, let's go and check it. If the member OA rotates with an omega clockwise, therefore the B gonna move horizontally to the right or to the left? Definitely to the right. That's why the velocity of B is gonna be to the right. We're gonna make perpendicular on the first velocity, the velocity of A, and we're gonna make it perpendicular on the second velocity, the velocity of B. They're gonna intersect at this point, and this point is called I. It is the instantaneous center at this moment. What else do we know? We know this. We know that here the B and the point O were on the same plane, and this angle was 30 degree, and we know already that these are on the same level, so definitely this angle is gonna be 60. And what else do we know? We know that this angle is equals to phi, which is 7.18. Therefore the remaining angle of the 90 equals to 82.82. And now we can find that this angle equals to, let's call it anything. So it's gonna be equal to 180 minus 82.82 minus 60, so it's gonna be 37.18 degree. We know the length of the AB, we know the three angles, so we're gonna use the sine rule or the cosine rule. Definitely it's gonna be the sine rule. Let's write it here. In triangle IAB, I'm gonna use the sine rule, so it's gonna be IA over sine 82 equals to IB over sine 37.18, and the final one is gonna be AB over sine 60. And we know already that the AB is equals to 0.8, therefore we can know that the IA equals to 0.917 meter and the IB equals to 0.558 meter. Okay, now we can get the omega. So the omega of AB, it's gonna be rotating around the point I, and the omega therefore is gonna be in this direction. So the omega AB is gonna be rotating counterclockwise, and we can say the following: VA equals to omega AB times IA. Therefore omega AB equals to VA over IA. TA equals to 3 meter, IA equals to 0.917. Therefore the omega EB equals to 3.272 radian per second as SI units, and it rotates counterclockwise. The final thing, now we can get the VB. The VB is gonna be equals to omega AB times IAB times IB. We know already that omega AB equals 3.272 and the IB equals to 0.558. Therefore the VB equals to 1.826 meter per second, and its direction is going to be to the right. This is the final answer of this problem, and was the required as shown here. Find the velocity of VB. Let's go to the next problem and see if we can solve it or not. This problem, we can see that there are the member OA 0.7 meter length over 45 degree, member EB 2 meter length and it is horizontal, and finally the BC is, the length is not given but the angle was 55.6 and O and C are on the same level. Given the omega BC is equal to 8 radian per second clockwise, find omega AB and find omega OA at the given instant. Okay, so let's try and solve this problem. So before starting this problem, we can see that the length of BC is unknown and definitely we will need the length. So how can we get it? Easy. You can see that the A and the B are on the same level and the point O and C are on the same level. Therefore this green line will be equal to this green line, right? Definitely. So we can get the left green line by, the left green line is 0.7 cosine 45. Actually it's gonna be sine 45, but of course the value of sine 45 and cosine 45 is the same, and on the other green line is gonna be BC cosine BC sine 55.6, BC sine 55.6. Therefore we can find that the BC equals to 0.6 meter. Great. Now we can start solving this problem. With the given was omega BC, the 8 radian per second. Therefore we're gonna start analyzing the member BC. Here we are. Member BC was rotating around a fixed point, the C. Therefore rotation about fixed axis. I'm writing here the keywords so I can remember the way that I'm gonna solve this problem using the rotation about fixed axis. Here is the first member and the omega was in this direction. This was the omega BC. Therefore we can find that the VB is perpendicular to the member BC in the same direction of the omega, so this is the VB. The VB is gonna be equal omega BC times the length BC. We know already that the omega BC is 8 and the BC is 0.6. Therefore the BC is gonna be, the VB is gonna be equal to 4.8 meter per second. This angle was 55.6. So this angle will be 55.6 and the remaining angle will be 90 minus 55.6, which will be 34.4. Okay, so we can say finally that the VB will be equals to 4.8 meter per second with 34.4 angle. Okay, let's go to the next member, AB. Member AB is general motion. So to analyze the member AB, we need to know the direction of the velocities of the 2 points A and B to get the instantaneous center. But we know already the velocity and direction of VB, but we don't know the direction, neither the magnitude of VA. So we should go first to member OA and let's go back at the end to member AB. So let's start with member OA. Member OA is as follows. Member OA is rotating around a fixed axis, so it will be solved using the same method. So let's draw it first. Okay. If the BC is rotating with omega angular velocity clockwise, therefore also OA will have an omega in the same direction clockwise. So we know already that the omega of this member OA will be in this direction, right? Okay, so this is O and this is A. Now we need to get the VA. The VA is gonna be perpendicular in this direction. This is the VA, and the VA is gonna be equals to omega OA multiplying OA on which angle? This angle was 45, so it's gonna be over the 45-degree angle, because this was 45 as well. Okay, so since this is the VA, now we can go to the last member, the member EB. We remember that the member EB was not translation, and it wasn't as well rotation about fixed axis, so it was general motion. So let's draw the member first. This is the A and this is the B. We know already that the VB was like this, and it was equal to 4.8 meter per second and over an angle of 34.4. We know already that VA will be in this direction, but we don't know the magnitude of VA, but we know the angle of VA was 45 degree. Now we can do the following. We can take perpendicular over the first velocity and perpendicular over the second velocity. They intersect here, so this is the point I means the instantaneous center, which means the center at this instant exactly. So since this is 45, so the remaining angle will be 45. Since this angle was 34.4 and this is 90, so this angle will be 55.6. Now we can get the third angle. It's gonna be 180 minus 55.6 minus 45, so it's gonna be 79.4. Now we know the three angles and we know the length of the AB, so we can get the IA and we can get the IB using the sine rule. So let's say using the triangle IAB or AIB using the sine rule, it's gonna be as follows: IA over sine 55.6, IB over sine 45, AB over sine 79.4. The AB is already known and it was 2 meter, so we can get that the IA equals to 1.679 meter, and the IB will be equal to 1.439 meter. This is the IA and this is the IB. So now we can know that the omega of this member is gonna be in this direction. This is the omega EB, because the VB, the 4.8, rotates around this point, and the VA rotates around this point, so the omega is gonna be counterclockwise. Let's find the exact value of it. So it's gonna be VB is already known, equals to omega AB times IB. Therefore omega EB equals to VB over the length IB. The VB was 4.8 and the IB was 1.439 Therefore the omega EB equals to 3.336 radian per second counterclockwise. This is the omega EB. Now we can get the VA. The VA will be equals to omega AB times IA. Omega AB was 3.336 times IA, which is 1.679. Therefore the VA equals to 5.6 meter per second over a 45-degree angle, and here is the VA. The remaining thing was to find the omega EB and the omega OA. We know already the VA. Now we can find the omega OA from member OA. We have previously calculated that the VA equals to omega OA times OA, and now we can find that the omega OA equals to the VA over the length of OA. So the VA was 5.6 over the OA, it was 0.7. Therefore the omega OA will be equals to 8 radian per second, and the direction of the omega OA will be clockwise as previously found. This was the second problem. I hope that this was clear enough, and let's meet you in the next video in the next week. Good luck.